All right, well, we've looked at convergent and divergent series. Convergent series being one where the absolute value of the common ratio is less than 1, and a divergent series being one where being a series where the absolute value of the common ratio is greater than or equal to 1. Now we're going to move ahead and we're going to be calculating the sum of an infinite series. And so we see here that the sum of an infinite series, when the absolute value is less than 1, but can be given by this formula. The sum is equal to A1 over 1 minus R, which R, of course, is the common ratio. Now, if the absolute value of the common ratio is greater than or equal to 1, well, then the series has no sum. No sum exists. All right, so let's take a look. We're going to find the sum, if we can, of a couple of infinite geometric series. Well, let's see if we can find the sum of an infinite geometric series. This is going to correspond to page 684 in your textbook, example 2. And we're given two geometric series here. Infinite geometric series, I might add, because we know this. Why? Because we see this dot, dot, dot sitting out here. So let's take a look at this one on the top. So I've got an infinite geometric series where the first number of the series is 4, second number is -2, third number is 1, fourth number is 0.5 or 1/2, and then it goes on forever. So if I'm going then to determine whether this, if I can find the sum of this infinite geometric series, my first step is to calculate the common ratio. And I'm going to do that by taking this second number in the series and divide it by the first number in the series. I can already see a pattern here because I go from a positive to a negative to a positive to a negative number. What does that tell me? I know that my common ratio is at least going to be a negative number, and I'm going to prove right now whether that common ratio is less than 1 or if in fact it is greater than or equal to 1. And you can probably look at this and pretty well tell that it is going to be less than 1 because I've got -2 over 4, and that is -1/2. So I can in fact find the sum of this series, and so let's do that. Why don't we? So we've got S equals A1 over 1 minus R. Well, A1 equals 4. So I got 4 over 1 minus -1/2. All right, so let's see. So S is equal then to 4 over, well, 1 minus -1/2 is that's +1/2, so that's 3/2. So I got 4 over 3/2, which equals 4. So I'm dividing 4 by 3/2. That's the same as multiplying it by 2/3. And when I do that, well, 4 times 2, I can look at that as 4 over 1. 4 times 2 is 8. 1 times 3 is 3. And so the sum of my infinite series here is 8/3. Amazing. Now let's look at the second one. So here I've got an infinite series. I'm given 3 numbers. I've got 16 plus 20 plus 25. Everything's positive. I know my common ratio has got to be a positive number. Is it going to be greater than or equal to 1? Well, I can look at that and tell that's the case, but let's write it out. So I've got 20 over 16. Well, if I divide 20 by 16, I know it's going to be more than 1. And for this, that's all I really care about. And since the common ratio is greater than 1 and it's a positive number, so therefore the absolute value of the common ratio is greater than or equal to 1, then no sum exists. Oh well, can't get much better than that, can it? Not too bad. I told you this was a fairly simple chapter section. If you stay with it, you got it. Most difficult part's coming up here when we're going to deal with repeating decimals, but got to have a little difficulty in here, don't we?